Okay, we're given a graph that shows the height of a rocket at time t. Our goal is to sketch the graph of a velocity, the velocity of this rocket at time t. And it's important to know that the velocity is the derivative of the height function, so the slope of these tangent lines along the way. Now we're not going to go into a ton of depth on this, but big things to understand here. The big concepts are we want to understand that the derivative, in this case the velocity, is going to equal 0 whenever we have a horizontal tangent line. So as you can see on the right hand side, we've kind of drawn in some of these tangent lines that are going to be important. At the very top here, we do have a horizontal tangent line drawn across here. It appears that is located right about 5. So that's going to correspond with 0 on the derivatives graph, or an x-intercept. All right, another kind of important key point on this is you'll notice over at, I guess that's 8, it matches up here that our graph kind of has this cusp along the way, or a sharp corner. So we want to take that into account as far as that's going to affect our derivatives graph. The other things are more important here, though, that we understand that if our tangent lines are positive, meaning the graph is increasing, such as what we have on the left-hand side here where I'm putting the plus signs, then our derivatives graph is going to be drawn above the x-axis. We can't draw it below the x-axis because all those tangent lines are positive. Now they do trend down towards 0 where we have that maximum, but notice on our derivatives graph we're only drawing above the x-axis. That's important. To the right of 5, between 5 and 8, we are decreasing, right? It's going downhill if we look at that original graph, meaning that we can only draw below the x-axis for our derivatives graph. All right, we could get estimations on those and get a more and more accurate graph. The other thing, though, to note is off to the right here from 8 to 10, or we can assume that keeps going forever in that same direction off to the right, that's going to be a constant function. All right, meaning it's a line going on here. Now it will be drawn below the x-axis because it's a negative slope, but it's a constant, and as we've seen with constant functions, they have a slope that stays consistent the whole way through. So it's just going to be a horizontal line on the derivatives graph. All right, those are the big things. Identify whenever the derivative is going to be 0, meaning a maximum or minimum. Put that on the graph, and then be able to identify increasing derivatives only above the x-axis, decreasing the derivatives only below the x-axis, and yeah, constants are going to be horizontal lines. That's handy to know about as well. Hope this helps you understand how original functions and their derivatives connect together a little bit better.